Hello, gentlemen. Now we have already seen the changes in the function when the reference side is changed from the x-axis to the y-axis. That means first we go for the acute angle when the base is at the x-axis. For the second quadrant, which makes the total angle of 90 plus theta, for showing the value of theta in excess of 90 degrees, we now use the different axis, that is the y-axis, which was previously the x-axis when the acute angle was shown. Now, as the sides are interchanged from the x-axis to the y-axis, the side used as the base in the first quadrant will be used as the perpendicular when the angle is in excess of 90 degrees but within the 180 degrees. So we have covered this discussion in the last video when the functions were shown to be changing for the 90 plus theta. And this can also be represented as some angle less than the 180 degrees. So today we'll use the again x-axis as the base, which was being used in the first quadrant. And if we look carefully, here the functions would not change, because for the making of any function, if the sides are located along the same axis, then the base in one quadrant would be the same base in the other quadrant, because the base which makes the angle theta is along the same axis, maybe on the positive or the negative side. So in this video we'll be covering about the functions when you refer to the x-axis, that means 180 degree minus theta or 180 degrees plus theta, and we'll see how these functions behave. And it can be guessed that the function would not change, but rather the positive or the negative side would change, depending upon whether the perpendicular is along the positive side of the y-axis or along the negative side of the y-axis. So let's start off and see for the expressions of the values when you refer to 180 degrees plus theta or minus theta. Let's just name the sides is M and H, and the angle is here 180 minus theta, and the proportional side of M is, let's say, M1. For N it is N1, and for H it is H1. Let's derive the formula for the sine function of 180 minus theta. That would be equal to M1 upon the hypotenuse H1. The ratios are similar to M and H. That would be equal to sine theta. Here it can be seen that the sine function remains as the sine function without changing its polarity. That means the sine function does not get changed over to the minus of sine function. Cos of 180 minus theta, based in the second quadrant, N1 upon the hypotenuse H1. That is equal to the N H. Now we can see that N1 is in the negative side of the x-axis. So the value of N1 by H1 will be negative of the ratio of N by H. It would be equal to negative of cos theta. So here cos function is retained as the cos function itself, but the polarity gets changed over. Here it is positive, but here in this case it is negative. just because the base in the new case here is along the negative side of the x-axis. In this case, the function never changes as the base remains the base and the perpendicular remains the perpendicular. Of course, there is change in the polarity. For example, the tan of 180 minus theta, it will be same as the tan function, but with the changes in the polarity. P1 by B1 equal to the M1 by the N1, that will be equal to plus M, and N1 being in the negative side is now proportional to the negative of N. So that is why it is equal to negative of tan theta. The value of sec of 180 minus theta, it will be the negative of the sec of theta. Cosec of 180 minus theta, that will be obviously equal to the same cosec function, and about the cot of 180 minus theta, it would be equal to negative of cot theta. For the triangle, after being rotated by 180 degrees from the original position, the new hypotenuse is h2. So sine of 180 plus theta will be equal to minus m2 is proportional to minus m by h. So that would be equal to minus of sine theta. And about the cosine of 180 plus theta, that is equal to negative of plus n, cosine function of angle theta, of course with the negative sign. Tan of 180 plus theta will be equal to minus m2 by base is minus m2, that is equal to minus m by the base minus n, that is the positive of tan theta. For 270 minus theta, the theta is made at this place, and for making of theta we have used the y-axis. So as the axis have got changed over from x-axis to the y-axis for making the angle theta, it can be very well guessed that the functions will also be changed over from sine function to the cosine function and vice versa, along with the changes of the polarity. Sine of 270 minus theta, perpendicular now minus n3 upon the hypotenuse h3, that is equal to negative of the n upon the hypotenuse, cosine function with the negative sign. Cos of 270 minus theta would be equal to minus m3 by h3, which is proportional to minus of m by h, and that is equal to sine function, of course with the negative polarity. So it is seen that the positive polarity got changed over to the negative polarity, and the cos function also get changed over to the sine function. So the polarity as well as the function gets changed over, and tan of 270 minus theta is equal to minus m3 upon the base, that is minus m3, and minus of base by the minus of perpendicular, which is equal to positive of cot theta. So here also the function got change over from tan function to the cot function. So that is the reason the functions get changed over when the side which helps to make the angle theta gets changed over from x-axis to y-axis or vice versa. So this is all about why and how the functions change when the angle is changed from theta to all the way up to the 360 degrees, written in the form of 90 plus theta or 180 minus theta in the second quadrant, and 180 plus theta and 270 minus theta in the third quadrant. So that's all in this video, and we'll be discussing the other interesting topics in the next video. See you soon in the next video. Till then, take care of yourselves. Please give it a like and share it among your friends so that they can also enjoy it and be benefited out of this. Till the next video, take care of yourselves and bye bye.